designed to be put into that system. As a matter of fact, the documentation that we utilize to quote reference these two switches in there as existing. So we kind of knew what we were doing in putting all the comm in place, and all of the other switches are going to be exactly the same. So any spare parts will be applicable across the whole line. Any service information or the GWI, the instruction manual that we put out, they'll be the same for everything. We try to make sure that everything is the same so that there's not multiple documentation that you have to reference or anything like that. So, I mean,
is there any local that can service this stuff?
Sorry?
Is there anyone local that can service us?
Normally,
Like if I called the Hampton Tedder or the...
I mean, okay, so yes, I mean, the Hampton Tedders are going to be great for servicing your high voltage side, your cables and things like that. I mean, that's their specialty is when you do have an outage and a problem with your cable feeders, who you call? You're going to call Hampton High Voltage Services, DeYoung, one of these guys. Those are the guys that are the cable pulling guys. They're the cable termination specialists. Now, Hampton Tedder does have guys that they go out and will test these relays. They'll come out on a annual whatever basis, and they can come in, and that's why we have these test switches in here, so they can come in and simulate and test and verify that the relay is working properly. You know, so usually when we start one of these up, the contractor will have a third-party testing company come out. And he'll go through and run through and verify, do current injection, and make sure that the switch is operating properly, that it's tripping open, just like they would do on a switchboard or, you know, your main switch gear. I'm local. I have my card here, so if there's ever, you know, an issue, you know, I'm happy to come out and you know, I know I've been here.
I think you were the one that told us we needed batteries over there at the other building.
Yeah, that was the problem with that switch. Was the first time to energize it, they were missing the batteries, and so we couldn't close the vacuum interrupter. So we had to have that was
pretty good.
Yeah.
You just seen us the day before. I was standing looking at them.
Yeah. So there are the batteries just like that, and you know, feed into. So those batteries will only last so long, and if we've got the fan going, if it's a hot day or whatever, that may decrease the runtime of the batteries. I think you guys had an outage within like the last 2 months here.
Yes.
And I think that this switch maybe.
We had no problems with that whatsoever.
Okay. Yeah. So, you know, if, like I said, if you ever run into that problem where, you know, right now the power went out on, and you only had one feeder and it's not set up for auto transfer, and it sat in 8 hours, it was de-energized, the battery ran down. You can either bring 24 volt DC and jump it in there, bring in 120 volt AC and jump it in there, bring it back up, and then you can electrically operate the sources.
Hey Brett, just as a point of clarification, the fans are actually 120 AC.
Okay.
So you don't have any draw on the batteries when it comes to that.
If I lose power, the power
Okay.
will shut off.
Yeah, right. Yeah, the only way that the fans would, I mean, if the fans are, they're only going to run off of 120, so you'd have to lose both sources. If it were a DC fan, then you'd be talking about draw because it'd be coming off the 24 side.
But if I lose that 110, there's nothing going on in there anyway.
Correct. Correct.
Right. So, yeah, again, there aren't a lot of service companies. I mean, GW, we have. If there were something significant with the switch, we'd probably have a technician coming out of Chicago, out of the factory, to address anything significant with the switch. Your high voltage cable side, like I said, you're gonna have, you know, those guys come out. Something with this, again, likely you're going to call G&W. You got a warranty issue, whatever. Those switches are going to be under that. You're going to be talking with Sheldon for the next couple years, hopefully here, as you know. And that's why I wanted Sheldon to come out, because he's going to be handling that project down the road. And I'm sure, you know, your staff is going to be eventually working with him as he builds out that system and that controls. Because that system not only controls these switches, it's also going to control the main switchgear breakers. Because what you're going to have is when you have a fault on that loop, that switchgear, that feeder breaker in your main switchgear is going to trip open. That's going to be your first issue, right? You have a fault, goes upstream. Well, the switches aren't going to stop the fault going upstream, because these are just switches. They're not designed to interrupt. So they're going to stay closed. These switches are going to stay closed and let that fault current go all the way back to your main switchgear. That feeder breaker is going to trip that feeder breaker. Now, that's going to initiate all of the logic in the control scheme to go, all right, I tripped my feeder breaker. And it's going to start going back, talking to each of the switches, seeing, okay, the fault was in between switch 4 and switch 5. Open that switch, okay, close feeder breaker.
It's going to reclose the breaker.
It's going to reclose the breaker, and it's going to re-energize that loop, isolating that segment. So that's the whole, I mean, it's not just the switches, but you actually have to control those feeder breakers.
In the factory, as part of the factory acceptance test, obviously that'll be simulated because we won't have that upstream switchgear.
Right.
But one thing I did want to mention as far as servicing, if there's a problem in the high voltage enclosure, that's one thing, or even with the controls, fuses, wiring, that sort of thing. We have our aftermarket service team. If there's any issues with the programming, I'm actually part of the automation group as the application engineer and one of the engineers that work on some of the design. So what we would have is we would have the individual that either worked on the program specifically or someone very familiar with the program to come out. So there may be a lot of things that he could do at his terminal as far as simulating and, you know, what are you seeing? You know, maybe have one of the AMS guys capture a report and send that over to him. But basically, we really want to stand behind this product by making sure that the person that has the most knowledge is going to be the one that's going to service it down the road. So what you'll find is the individual that does the factory acceptance test will probably come out, well, more than likely will come out, do the site acceptance test. So once everything is in place, the same guy that did it in the factory will be out here and he's got all the familiarity. If anything happens, call comes into me, call comes into the aftermarket group, we'll definitely reach out to that individual, and it may be something that he knew about that was being worked on or something that he can fix pretty quickly. At the very least, he'll make his way out here and work with someone on site to correct the problem. So, you know, we're definitely going to stand behind it for as long as the system is. There is some potential for expansion beyond this project, but, you know, built into the way that the communication system is set up. But for this project, for the 27 or so that are coming out, we'll basically test, verify, and support it all the way through, commissioning and beyond.
So, any questions about the operate? Yeah.
Regarding the SF gas.
No gas.
No gas. Okay.
No gas. No,
This is all
no
solid
SF gas.
dielectric.
Yeah.
Okay, can I
So
walk
while
through
it
the-
has a tank, and that tank, that air, it's filled with nitrogen.
Okay.
Just clean. It keeps any moisture out of there. So there is absolutely no SF6. There's no maintenance that you need to do.
Mainly electronics and all the bus cabling and so forth.
Right.
Yeah. Normally, we had to consider ambient temperature when we was replenishing the gas, and I was wondering, I didn't see anything.
Nope. Yeah, there's no, exactly. Now with the SF6 switches, right? The ambient temperature, because if it's 80 degrees, the pressure might be 10 and a half pounds versus if it's North Dakota and it's 10 below, it might be sitting at 5 psi. I mean the gas expands and contracts that much. These switches, nothing. These are we consider them maintenance free. There is no, other than coming and looking to see that there wasn't some type of rodent that got in and chewed on your cables, and that otherwise it's clean. That's the only maintenance that's required. No lubrication, no nothing like that.
Yeah, the mechanisms are rated for 10,000 operations, maintenance free, so that should, go beyond the life of the switch. All of the actual insulation is right here at the modules. So up here, you pretty much have, like I said, all the bus connections and electronics that operate. All of these cables that come out are tied into boards on the inside. And so, and this is actually another thing where, let's say that, you know, anytime these switches actually do need any sort of maintenance or anything, it's less about having to cut a tank open, you know, degassing it and cutting it open. Because there's no gas in there, all of these plates up at the top can be removed. And it's a lot less costly, it's a lot less time consuming, and all of the boards are basically organized in there where they're easily replaceable. They're kind of all plug and play as to the electronics and all the cables coming out. But all of your insulation happens down here at the bottoms.
Information.
All right. Thank you very much for guys coming out. And if
I get that a lot.
here's mine,
Thank you, sir.
if anybody needs or has any other questions, you can feel free to give me a ring at any time.
All right.
All right, thank you guys for that. Okay, we're gonna do the downside of the medium voltage from here out. So that 12 kV switch that feeds the step down transformers here. Yeah, this one here comes in 12 kV, steps down to 480 and goes into the dining commons building. This one here goes into building B, which electric room, which we'll go look at next.
You're not going to get into them?
No. No. All right, ready? All right, so we just came in from the medium voltage yard / generator yard. And the transformer we pointed out over there, the 12 kV, is stepping down to 480 volts, which feeds the main switchboard here, which is 4DMPD. And then at 480 goes to the distribution board, which feeds multiple different panels and or transformers for this dining commons building. There's this gear, and there's also a set of gear there, which is the fed off of here, the 2K DP1 switch gear, which I believe does all the kitchen equipment, and that's what the K represents.
Which one is that?
The stand-up section right over here. And that's fed off of 800 amp breaker off of here. I'm not exactly sure. Oh, it's a 400 amp, I'm sorry. This is it right here. Okay, so this feeds that other section there. And then from there, it has distribution breakers that go to different equipment and different transformers for step down for 120, 208 panels throughout. And that's pretty much it for right now.
So this been a switch for the whole tank or
I'm sorry?
just the switch here?
Yeah, that's the main for this.
It turns off everything. Right?
Everything goes down. Any questions in here? This is building B, main electric room, also coming off of the separate 12K to 480 transformer out in the generator yard, which feeds the main distribution board here at 4MDPB. Over in A, it'll be the same, but it'll be an A at the end. You have 480 coming in here, and which feeds all these distribution breakers, and which includes, I can speak a little more, I'm a little more familiar over here. So you got the two ATS switches over here that are fed from here. One does the lighting panel, the other one does the mechanical / elevator panels, along with a step down transformer for an emergency 120 volt panel here, which does quite a bit in this building. As you can see, it's got it's already pretty full with all the fire smoke dampers, fire alarm equipment, This is basically the only 120 volt emergency panel in the building. So it all came to here.
So these panels gonna have paper in them?
Yes, they do.
Because
Yeah,
they needed a,
We have the temporary ones. I have them being printed up right now. So during construction, we used the panel schedule from our prints and made any corrections or additions onto here. I didn't want to have the cards printed out before because I want to hand over a clean copy, not a scribbled out copy like that. So,
So the ATS switches, they come from here, these
Yes.
main breakers that labeled ATS, the 4 ERB1
Yes.
goes to the 4 ERB1 here, and then this 4 ERB1 goes to whatever panel, it's a 4 ERB1
Yes.
somewhere, right?
I believe it's the one right next to it. So it's those two
Yeah.
panels there.
So it would come there.
This is the
here,
normal
and then
feed
to
for the
And then
ATS.
to the panel.
So for instance, if you were to turn this breaker off, that ATS would lose normal voltage, send a signal, and within 8 seconds, the generator would be refeeding it with the emergency panel. I believe it's actually around 6 seconds we've been on a cold start. Once the generator's been running for a little while, it's almost instantaneous. It starts right up.
So if we need to shut down that panel that's tied to the ATS, then we would have to shut down the ATS, correct?
Yes.
Well, we would have to shut down the.
Well, the generator. You would lock out the generator
Yeah.
and lock out the
Right.
feed for this. And it definitely, even though the generator's not running normally, if you just turn this off, it would
kick
it would
on.
turn it
Turn it
off.
off right now, it generates.
It would, yeah, because it's got 2 start wires that go out to there. That if I were to turn this off, you would hear a click in there, which is sending the signal out to there. And that's pretty much in here.
What are all the, well, I'm just curious.
Oh, these are the meters for different systems here. I believe all the mechanical panels have a separate, so they can see what different loads are using power-wise. And they're all tied into the network, so they can be read off of the computer.
So George does
so which,
have to
yeah,
come
which one's
over
the
here.
main kilowatt hour, which you're gonna read?
It's probably this one right here.
We had a question for you also, it doesn't regard these, but the lighting in these mechanical rooms and stuff are these on backup generator or anything?
Yes, yes.
Okay.
All the electric rooms are 100% backup.
Backup?
Yes. And they're all toggle switch. There's no motion sensors. It's all just on or off.
Mechanical rooms too?
Yes.
Boilers are?
Yes. Actually, the mechanical room is half emergency, half normal, but the electric rooms are 100% emergency light.
I assume that, but
You never know.
yeah.
And more times than not, on jobs, you see a motion switch on the prints for an electric room, and that's against code. I know for City of LA it is, so I always put toggle switches on that. You don't want to be inside the gear
It
and
shuts off
have
by-
to
yeah,
wiggle
shuts
your
off
foot
by-
to turn the
yeah,
lights back on.
So these breakers here, these main breakers, how do we reset those? Is there anything special? They just turn off and on?
Yeah, they're just,
Down?
if it trips, you have to switch it to off and then reset it.
I'm
They're not
assuming
like the GE ones where you have to energize the spring.
Pump it and
Yeah,
stuff.
pump it, yeah.
Okay. So I'm assuming that little arm is just for
Yeah,
that
it just
extra
pulls out
leverage.
leverage.
Okay.
Yeah,
Gotcha.
most people can't reset that without that leverage thing. And the only other thing that I know about square D gear is your phasing. You'll have your A, B, and C phase on the left side, but it's actually reversed on the right-hand side. It'll be C, B, A. It's just something that square D has always done, and I have no idea why. But
Yeah, we don't worry too much about
No.
phasing once you set it up and you've already phased it all.
yes, and the phase rotation for this project is counterclockwise. That is what we got from the utility, so we matched it. So if you ever open this up and you notice that on the high side of this breaker we have yellow, don't say, well, those guys must not know what they're doing. That's the way square D gear is. And they're the only ones I know that are like that.
Cool.
And this is, actually I need to remove this. There's nothing on there. I just keep forgetting to grab the key out of my trailer.
That's it.
Extra extra.
It used to feed the temp power for the manholes.
So those will say spare on them also,
Yes,
right?
yeah. Yep, and that's it. Any other questions?
Pretty straightforward.
Yeah. Okay, now we're in building A. Same as before, the feed for this comes from the generator / transformer yard, bringing 480 into the main distribution.
Does this one
panel?
come from the generator yard? Doesn't this?
No,
come
I'm
from-
sorry, you're right. The transformer for this is on the outside of this building.
Okay.
And it brings in 480, which feeds this distribution board, which goes out to feed panels, transformers, and throughout the building.
So, all these here,
They're tied to a panel.
but like throughout the building too, and electrical rooms and stuff.
Well, these are monitoring, for instance, the
Not these,
oh
like the panels in the rooms,
Yes.
hallways and stuff.
yes, up in the electric room.
One of these is gonna shut one of those down.
Yes. Yeah, if you look at the single line riser diagram, it'll tell you that the transformer for P2.1, that's up on the second floor, segment 1. That goes up at 480, hits a transformer, and then that hits a distribution panel, which will feed the P panels on multiple floors.
So, yeah, if you had to work on one of those panels, you would kill it here.
Yes, or the main at that panel.
Okay.
All the panels have mains.
Okay.
And then, say if you go up to like the fourth, or on the second floor, this panel, not the transformer, but the panel after that will have breakers, 3-pole breakers that do different panels upstairs. So it just continues.
Oh, I got you.
So
Okay.
you should never have to come in and turn anything off, so just turn it on.
Upstairs, yeah,
Yeah.
wherever you're at.
So for instance, if you need to get up to the 6.1 panel, you'd probably go to the second floor, and that the breaker, individual breaker for that panel would be on the second floor. And you just have to look at the single line diagram for that. And same as the other building, we have 2 ATSs, one for the emergency lighting and one for the elevators. And the elevator one also does this transformer, which is step down for the emergency, not this one, it's upstairs. The emergency 120 panel is on the 3rd floor in this building. And that's the only 120 emergency panel in the building. And that's where all the fire smoke dampers and fire alarm equipment is fed from the 3rd floor.
So is that meter blank for a reason?
What's that?
Is that meter blank for a reason?
If you come back after tomorrow, it'll be lit up. There's one or two that are being replaced tomorrow by Schneider, which is the parent company of Square D. They have a tech coming out tomorrow. And, must have got damaged during shipment or something. We're
I'm
not
coming
sure.
back tomorrow.
Yes.
I'm coming back tomorrow.
Okay. No problem. He'll be here. He'll be here at 7 a.m. that day. Here, if you were to open this up, it's pretty much isolated. You can do it. It's not. There's no bus bar in there, but there's little. Well, I can show you. So there is 480 in here, but these 3 meters here are fed. If you needed to isolate them or turn them off, there's 3 little busman breakers in here that feed those. In each little bucket here. So, and you see the data line, which is daisy chained from bucket to bucket. Then it goes back to the BDF room, so they can pull it up on the network and see the power being used. Just like the medium voltage stuff, switchgear is starting to get a little more utility meter, but other than that, none of this used to ever be in there. It's like the day of the meter reader. It was pretty much, that's what my dad did 50 years ago. He was a meter reader for Edison. I don't think those guys are on their way out.
They just drive
Yeah,
around
yeah.
with a big.
Actually, just passed away last week, but yeah, he worked for him for, thing. That's why I'm not really 100% here right now, but he would want me to move on, so, like we're doing. That's it. You got any questions?